Hi, and welcome to a series of videos about the Iterator pattern, which is one of the patterns from Gang of Four. So I'm going to go through what the Iterator pattern is. I'm going to show examples from Java, the built-in examples. I'm going to show some examples from JDBC, and we're also going to show how can you implement your own iterator. I'm going to put it into 3 different videos. So this first video is just about what is the iterator pattern. So oftentimes when we have some collection of objects in our program, we can have them, let's say, in a classic like array style. So we can have some values, could be integers like 3, 4, 5, 7, 8, 2, 1, 0, something, or 6, or whatever that is. And what we often want to do is we want to go through all of them. So oftentimes we'll write some code like, let me show you something here, like we would do a loop like this. So we would say if we have an array, like in array, my array equals, and then we have some numbers, something like that. We would want to loop over this, so we would say something like, let's loop over this array until we reach the end of the array, and then we can do something with that. So we put I here, and then we could do something with that. We could evaluate that. Something like that. And then we could do something. So this is not very useful, but you probably get the idea that you see this a lot. We have an array, we have a list, we have something like that, and we run through the entire list in order to try to actually get through all of the data in the list. So this is a simple structure. So what this does is it goes from the first element in the list to the last element in the list. So this is what we often also refer to as traversal. So we go from the first we point to element number 0, and then we jump to element number 1, and so forth until we jump at the end with the steps along the way, of course. We go to the length of the list -1, because it starts with 0, right? But there are actually other ways we could do that. We could also imagine that we had the same kind of data here. Let's say that this is just the same list. I don't want to write the numbers again, but let's say this is the same list, but now we want to traverse it in the opposite direction. So we would want to go from the last element, and then to this element, and then to this element, then to this element. So it's still the same data, but we are traversing it in a different way. Can also be that we have some kind of different way that we want to do it. Maybe we want to start at the middle, then we want to go here, then we want to go here and check something. If that doesn't fit, we go back. So we want to kind of step back and forth and stuff like that. Maybe jump to the start, maybe jump to the end, something like that. There's many ways we would want to do this. Sometimes we don't have a nice structure like that. We have even nicer ones. Like we could have a tree-like structure where we have an object that points to other objects here, that points to other objects. Could be a file structure where some of it are nodes, and so it could be files and directories, stuff like that. And you can imagine a tree like this could be pretty big. So then you can also traverse this. You can go from this element, and then you can go this way, or you can go this way. or you can go here first, and then go deeper this and this. So there's kind of like, you can make a route here, 1, 2, 3, 4, 5, or you could start here to the right, or you could start at the bottom, take the bottom ones first, and then go this way. So there's endless possibilities on how to do that. But what we oftentimes just want is, we just want the elements in some uh, um, particular order. So what the iterator pattern does is, it creates an interface for how to traverse a structure like that. So in its simple form, it has like an array, and like this. The iterator would then be able to say, on the array, we would then want to have a method that's called next. And of course, it would be on the iterator of the array. We would call the method next, and that would move the pointer to the next element based on however I set my iterator up. So it could be something like, let's go in here. So it would be something like, if I had my iterator like this, equals new my iterator, and then maybe the array that I'm going to work on. I know I haven't defined this class yet. And then we could do something like my iterator dot next, and that would then return the next value in my array. So instead of doing a loop like this, a for loop, we could do something like, we could say while my iterator dot next, that could return, normally that would return something like a Boolean, so that we would know whenever there's no more elements in the list, whenever we come to the end of the list here, this will be false. So if we go back to here, so I would then say something like, could be my iterator, and then something like that, get value or whatever that is for that iterator. So there's different ways to build this. There are some of these built into Java, and one of the common ones where we have a built-in iteration is that we can, for example, iterate over this array just by writing for, and then we can write int like this, I, and then we can define by colon that it's in my array, and then this will actually iterate over all of these in order from the 0th element to the last element here. So this will basically, this is the same as this. But the cool thing here is, we don't need to think about, we just want to go through all elements. We don't want to think about this I value here. If we're not really utilizing it for anything, why even bother about knowing about the I value here if the index doesn't really matter? So in these cases, we would often do something like this, where we would take, doesn't need to be I, it could be V for a value. So V here is not like I here, like the index, it's the actual value that is in this array here. So if we print this out to screen like this, V, oh, I deleted my array, just a second. That's the only thing I actually wanted to keep. So if we print out these values here, we can see it prints out the values from start to finish. So that's basically how it works. It works by or what it does really, it's not how it works, but what it does, it goes from one element to the next. And if we were to explicitly work with the iterator from this loop here, I'm going to show that iterator in the next video. We can actually fetch the iterator and see where are we right now in the list if we wanted to do that. And then the iterator could tell us where we actually are, but we could also imagine that we could configure the iterator to actually iterate over the collection here. Now this is an array, could be like reversed order or something like that. So we could create our own iterator that could reverse that. So the general pattern for that, I found that on Refactoring Guru, which is an excellent source for this, is that normally the way you do this is you have something like this, and it seems a bit big here, but I'm going to explain that in more detail in my last video, where I'm going to show how to implement the actual pattern. But the idea is that the iterator interface declares the operations that are required for traversing it. So this one declares what do you need for fetching the next element, and one of them here is that it has something like a getNext method, and it also has a method here to check if it has more elements in it. And has more will just return bool, so we could use that for a while loop to step through and say while it has more, get the next one, and then getNext will return that concrete object that we are going to be working on. And that is just this is just an interface to tell which methods that are on this kind of iterator. Then we have the concrete implementations of the iterator, and that iterator will hold a collection of data that it wants to iterate over. And we also need to save the state, and the iteration state might be where are we right now in the list. If this is an array, we want to save, for example, now we are, sorry, that wasn't 2, like this is 2, this is 1, this is 0. So the iteration state for an array could just be this value here that we are at index 2. So that could be the iteration state. This is also where we could put something like, we could actually put something like iteration pattern or something like that. We could put that on here. So say it should be from start to finish, or from finish to start, from the, should it go this way or this way? But this general pattern doesn't take that into account. Of course, I can show how to do that, but this just goes like, this is one simple iteration going from whatever is defined in this concrete iterator and going just forward. And all in a something like an array, this would be just to go from first element to last element. This is what you would expect from a collection like that, where the order is important. And this is working on a concrete collection. So we have our concrete collection here, which is the actual collection of data that we're actually working on. And this, of course, also works on an interface. So the client needs to know about the interface of the iterable collection, and the client needs to know about the interface of the iterator. And this is, of course, to achieve some decoupling between the concrete implementation of these two. We only want the client to know that it can do get the next and has more. And it also has this interface here that in order to actually create the iterator, we want the iterator to come from the actual concrete collection. And the reason for that being that there can be different iterators for different collections. In the sense, if we're iterating over a tree, this concrete iterator might be a tree iterator. If we're iterating over an array, this concrete iterator might be like an array iterator. But commonly, they would all have this interface here for actually working with that. If we wanted to support something like multiple ways of traversal and stuff like that, we would need to put it onto this interface, or maybe even have another interface and class for traversal or something like that. So in these videos, I'm going to focus only just on this simple implementation, not to convolute things too much. That was kind of it for the first part of this video. So in the next part, I'm going to show some implementations of the iterator pattern in Java. So these are examples where Java is already using iterators.